All right, this one's a little bit is about the mean, median, the mode, the three measures of central tendency, meaning the central just means like the three numbers that kind of describe kind of whereabouts everybody is, okay? We're going to talk about why you're going to use the mean sometimes and the median and the IQR and the mode other times. So let's just talk about how you can think about them when you look at a histogram, okay? So the histogram, the area represents the percent of the values in the set, in the data set, that are in like those places. Like if it's heavy up here, we know, or down here, it's a lot of low values, or if it's up here, a lot of high values. I'll show you, or depending on, I guess, the way the axis is. But let's take a look. One way to think of the mean is the mean we generally think of as the balancing point. So if you see something like this, a histogram, obviously you can see the balancing point would be right there, right? Right in the middle. And that's pretty cool. But what happens if there's one more value right here? That thing's going to go, so what's the mean going to have to do to keep the balance? Where's that fulcrum going to have to go? That guy's going to slide down like over to here to kind of keep that balance, maybe even further. Because the mean chases after the outliers, okay? Because it needs to keep that histogram balanced. The same thing, imagine the mean right here balancing. And imagine if I cut this whole part off and just spread it out around here. Now where's that mean going to have to go? Well, obviously it's not going to be balancing here anymore. It's going to have to run down here. The mean chases after the tail. The mean chases the tail. The mean chases the tail. Hi-ho the dairy-o. The mean chases after the tail. You got to balance. Okay. So you can see in something like this, the mean would be, well, somewhere right around here, right? A big bimodal distribution. There's like maybe heights of people in a classroom. There's some students and some teachers or something. I don't know. But that would keep it balanced. So if I was going to describe bimodal, I'm probably not going to use the mean because it doesn't describe anybody. Probably won't use the median either. When you have something that's bimodal, I'm probably going to talk about the two modes. And let's talk about so that's a mean, the balancing point. The median splits the area in half. It splits area in half. So you can see if you have a distribution like this, you know the balancing point's there and the area is split in half there also. So here's my mean and my median. It's half the area. But let's go over here. Boop. I added a little bit of area here, so I might have to slide the median over a tiny bit. But where's the mean have to go to balance? The mean has to run down here. Mean. So the mean was really impacted by that guy out there. The median just splits the area of the histogram in half. So if you see some weird histogram and you're trying to kind of guess where the mean and the median are, so you see a histogram, suppose it looks like this. Well, I've got to balance this thing, not balanced, not maybe, no, balance would be like right around, probably like right around here would be the balancing point. But now I got to figure out the area, and that's a lot. I bet you the area in half is probably like right around here. So that's probably the median, because if I squish this down, I could probably cover that. That's the median, that's probably the mean, the balancing point. Then what are the modes? The modes are just the peaks of the histogram. Wherever there are peaks, those are modes. We always say the mode is the most common, but sometimes in like a large data set, the mode might not even be, it's the top of the histogram where things are gathered on. Sometimes the mode doesn't even come up at all, which is possible. So the mode are the peaks. The peaks of the histogram. So remember, the mean is the balancing point. The median splits the area in half, and the mode is the peak or peaks of the histogram. Use the mean only when it's unimodal and symmetric. So when it looks like this, use the mean. If it looks like this, skewed, you can use the median. Or the mode, but the median. And if it's bimodal, you're certainly going to talk about both of the modes. When it's bimodal, use the mode. The other thing the mode comes up pretty handy is with categorical data, right? We had examples like if we're going to find out music preference in school, hip hop, country, or top 100 music. You're not going to say, well, the average student likes hip hop 0.58. Now, you can't like find an average. So if most of the students like hip hop, you say, the average kid likes hip hop. In that case, that's the mode because that's the categorical variable that comes up the most. So we use the mode in that case also. Last thing, remember we learned this thing, mean, median, and mode? You've been doing it like your whole life and you remember that order, mean, median, mode. So a way to remember their positions is a skewed left diagram. It's kind of cool. So you can just put this in your mind, skewed left, okay, way skewed left. And in that order, what's interesting is, the mode's right here, the median cuts the area in half, and then the mean is right here. It goes just in that order. Mean, median, and mode. Right in that order. So a skewed left diagram, half this area is about the same size as this. The mean would have to be like way out here, okay, to kind of balance it. And the mode would be right here. It goes in that order because the mean chases the tail, okay? Hopefully that helps you out. Thinking about these three things. Balancing point, splits the area in half, and the peaks of a histogram. Have a nice day.